Hello, everybody. Welcome to the NCFI Deep Injection Theory, Process, and Projects webinar. We're just going to wait a few minutes, give everybody a chance to catch up and get in. So we'll get started here in about 2 minutes. Need to figure out how to get some good music going during this time. Hello, everyone. We'll get started here in just a couple of minutes. Just going to give everybody a chance to join. We're obviously a minute early. Hello, everyone. You are here for the NCFI Deep Injection webinar. We'll get started here in about 1 to 2 minutes. I'm just going to give everybody a chance to join in. Hello, everyone. We're going to get started here just in about 1 to 2 minutes, just giving everybody a chance to join us today. All right. You're here for the NCFI Deep Injection webinar on theory, process, and projects. We're going to just get started here very shortly, just giving a couple minutes for some folks to join on. All right, let's go and get started. Hello, everyone. Welcome to the NCFI's Geotechnical Deep Injection webinar. We're excited to have you all here today to talk about a subject that's near and dear and probably one of the most asked for subjects that we have within the geotechnical polyurethane applications. Kevin, can you move to the next slide, please? So just some housekeeping items real quick. Approximate length is going to be about 1 hour. There will be a Q&A session at the end that may extend that. Obviously, out of respect of all your time, if 1 hour is what you have, feel free to drop off. But, the Q&A session usually brings up some really interesting discussion. The chat is available to ask questions or to correspond with the meeting host, myself. So if you're running into any kind of issues or you have any questions that you'd like to ask on there, please correspond through the chat or through our Q&A session. But we'll try to do our best to make sure that you're properly supported so you can attend this webinar. We are recording today. There will be a webinar link, recording link that will be sent to you via email through Zoom. But if you, after the email or within a couple of days, if you would like to see that and you do not have that link, feel free to just email me direct. The email will come from me, the follow-up email for the email, so you should have my contact information there. And again, I mentioned the Q&A session is going to be at the end. Next slide, please. So how to ask questions. So in the bottom bar of the Zoom window, there's a Q&A box. Click that. Then there's a ask question, click the ask question, and then enter your question and click send. Pretty easy, pretty simple. I think the majority of us have gone through that these days, given the prevalence of Zoom. That being said, I do recommend ask your questions throughout the webinar. We will be saving all the questions at the end, but it always makes, especially as a host, it easier if I've got questions to ask at the end as opposed to waiting a few minutes. So please, as questions prompt up, ask them, and we'll be thankful to have those at the end, and so others. Next slide. And now to introduce our speaker today. I'd like to introduce you all to Kevin Irwin. Kevin, he's a territory manager for the Central U.S. Kevin's been around geotechnical polyurethane since 2006. He's worked with some of the biggest companies as far as geotechnical applications or polyurethane is concerned, including Eurotech, FS Geocon. He joined NCFI in 2019, and he supports customers throughout the central U.S., including the Gulf Coast of Texas to North Dakota. Kevin, welcome, and looking forward to hearing your insight today, and I'll let you take it away.
Sounds good, Robert. Thank you very much, and welcome everybody. As Robert said, my name is Kevin Irwin. I am really excited to be here today, slightly nervous. But this is a topic that's near and dear to my heart, something that I became involved with in 2006, beginning in 2006, and have been part of at least since then. I wanted to get through, just talk about make sure we're all on the same page, and talk through some basic polyurethane chemistry. This will be very quick. But I do want to make sure that everybody's up to speed and we're talking, apples to apples here. First off, why geotechnical polyurethane? Of course, it's strong structural properties, minimally invasive. But the main thing about geotechnical polyurethane, and what I always think of, is that it goes in as a liquid and it rapidly expands and turns into a solid. And we're talking specifically, mostly about dual component polyurethanes right now, but that fits this. That's one of the main benefits, because it goes in as a liquid. It forms to whatever shape it's placed into, or whatever shape it makes. If it's placed in, when it expands, well, then we have a lot of benefit that you can see right here. There are two main components with the systems that we'll be talking about, dealing with deep injection today. Dual component polyurethanes have an A side and a B side, same as spray foam insulation goes in attics and the walls of buildings and homes, and of course, for our application in the geotechnical side, typically underground. And so that A side and the B side, those two combine at the tip of a injection gun, whether it's an impingement gun like the one you see here, or could even be have a static mixer on it, but it's got to be in a 1-to-1 volume ratio of A to B. Heats at the proper heat and at the proper temperatures, and then you make good foam. So dual component systems contain everything that's needed within those two to react. You don't have to add anything. So even additional water in the system is using the right chemical. Even having water shooting into water is not going to be a problem. I do want to just mention that there are single component systems out there. They have, we call them single components. They do have catalyst and some other things in them, but the primary activator component of that is the prepolymer. So it's more like an A side. In fact, it's mostly A in a lot of ways. Now, I'm not a chemist, so please don't get me for saying that one, but we can add catalyst to speed up the reaction. But one key component here is that moisture must be present for these single component systems to react. And so we're talking about the dual component systems when we're talking about deep injection for soil stabilization and today. So dual component systems, everything you need is already contained within the two drums. So you're going to get a good chemical reaction. Single component systems have to react with water. There is a lot of crossover between the two types of systems. They do have their strengths. So dual component systems have that higher expansive pressure. They're typically our lifting formulas. Single component systems tend to have lower expansive pressure. And no lifting. Of course, you put enough pressure behind anything, it'll lift. But you're not going to be as likely to lift with a single component system. A few other things, on the dual component side, system specific speeds. The single component is field adjustable. But if we look at the crossover applications, water cutoff, stabilization of soils in the right conditions, they can both do. undersealing of slabs or structures, and soil densification, all in the proper context. We need to talk about density. Deep injection works on the principle of confined density of the chemical as it expands. So density, of course, how much, it's a measure of mass per volume. So if I have a volume that's 1 cubic foot, and I fill that with what we call a 2-pound foam. The industry term is 2 pound, 3 pound, 4 pound, 2.8 pound, 4.5 pound. When we talk about that, as we talk about different chemical formulas, that's what we're talking about, the density per cubic foot. And so that density per cubic foot can change, but when we inject it into the ground, when it's confined. But a 2-pound density cubic foot, 2-pound density, sorry, is if I have 1 cubic foot of that system, it's going to weigh 2 pounds. That sounds straightforward, but we need to understand that that foam can pack, because it starts out as a liquid, and we're injecting it into the soil, and then it begins to react and expand, and now things change. So why is density important? Well, it determines how much chemical is needed to fill a void. If I've got a large void to fill, of course at NCFI we do have large void fill foams, and that density of the foam is going to directly relate to in a pure void how much foam we're going to use. Now the quantity of not just the volume to fill, but the quantity, we have density is going to be directly related to that. And of course, it's the single largest determining factor in a foam's strength properties. And the reason we talk about density is because in the lab, as a manufacturer, we test free rise density of all of our poly systems. That free rise density is unconfined, unconstrained during the reaction, or during expansion. As you can see on the picture, the image on this slide, you can see cups in the lab, and they've mixed samples and it's risen out of the cup. That's a free rise density test. We do free rise density spray tests as well. But that free rise density is what we're talking about when we say 2 pound, 3 pound, 4 pound. But because of the properties, or how polyurethane works, I tell my customers that I don't sell polyurethane foam. On the geotechnical side, NCFI does in other parts of our business, but on the geotechnical side, I don't ever sell polyurethane foam. I sell the chemicals to make polyurethane foam. The operators in the field, as they're pulling the trigger, they're making combining the two liquids, and they're making the polyurethane itself. And that process, because it goes in as a liquid, fills up a void, and then begins to rapidly expand, when that process of expansion is limited by a slab over the top, soil around it, the foam will tend to pack. And that means that our 1 cubic foot space that we were filling with 2 pound foam, what happens if we get, make that a half cubic foot space, but put the same volume of chemical in there and allow it to react? Well, if it has half the space to expand into, the foam is still the chemical reaction is still going to go on. It's still going to occur, but the foam will pack and become more dense. And it's that principle of packing that's going to make our deep injection function. Selecting the right polyurethane, there's a lot of different, at NCFI Geotechnical and NCFI, we have many different formulations. We have a lot of different formulations even for lifting on the geotechnical side. But we're going to be looking at geology, soil types, whether we have water present, how heavy is the structure you're trying to lift. So there's a lot of different formulations that we need to look at, and make sure that you're using the right formula for the job. That is typically oftentimes a question for, your representative. We have a geotech team that is well experienced in helping pick out that right system and then applying it properly. We're going to be looking at reactivity time, the density, of course, and project goals. But the main thing to understand here, we have fast reactivity foams. So faster formulas. You get pinpoint lifting and control with that, but of course you're not going to get very deep with it. As the in the image you see here, the tip of the gun, the chemical mixes there, it goes down the tube, and it's already reacting as it's going down the tube. So you will plug the tube with a faster reactivity foam more quickly, depending on the depth you're going. Slower reactivity foams tend to, we can get those down further. We can manipulate heat to a certain degree to allow us to get a little bit further or react a little bit faster or a little bit slower, depending on the amount of heat we add at the injection point. So slower reactivity foams are going to go deeper. And of course, we need to pick the right foam for the density. That starting density, the 2 pound, 3 pound, 4 pound, that's you can think of that as a it's the void density. In other words, if that particular system, a 2 pound system, is injected into a void, it's going to be roughly 2 pounds per cubic foot. However, if we inject it under confinement, it's going to change. That density will increase, but it won't go below the 2 pounds that we measured in free rise density in the lab. And of course, project goals. In our case, we're looking primarily at the void filling, soil densification, increasing load bearing capacity, but even slab lifting and realignment can all be done with deep injection. All right. Deep injection. This is the process of injecting, rapidly expanding polyurethane foam at depths in order to stabilize or under confinement to densify soils and stabilize structures on top. We're going to be injecting through casing. Typically, we're using steel tubing. Other types of tubing can be used, but half-inch steel tubing has always been kind of my go-to. It's easy to get down in the ground. It's not too big around. It's got a nice thick enough wall we can drive the tube, but we don't have to have a tube inside it in order to drive. And as we go deeper, we're increasing the opportunity and increasing the likelihood of more packing of the foam before it begins to overcome that packing and one of the resistance around it. And we're going to be injecting in a 3 to 5 foot horizontal and vertical grid pattern. These are all typical numbers. This will adjust depending on the type of system you're using, depending on the type of soil you're in, and of course the depth that you're needing to inject. But that process, not only in the x-axis, but also in the y-axis, we're going to be injecting down, typically starting top down and then moving down to the lower levels. So we'll typically inject the top levels and then move down instead of bottom up, but we will discuss the options there here in a bit. So as we're injecting at the top, we're measuring at the surface. We're making sure that watching for any movement at the top of the slab. That movement is going to be measured with varying devices, but we may be looking for a movement of, a 1/16 of an inch, and that may be good enough, or we may be looking for more. But the point is that we're continuing to inject at these deeper levels. And as we get the confinement and expansion of the foam, that leading edge of foam, as it's liquid, it's combining with the soils. It's then, as it's combined with the soil, it then begins to expand and it's pushing on the soils around it. And it can be multiple levels. It can be one or two levels deep. Wanted to define a couple of terms. Obviously, deep soil injection we're talking about, but with deep soil injection, we're injecting directly into the soil. With slab lifting, which is what many people are familiar with, we're talking about, driveways, sidewalks, even residential, commercial, lightweight commercial slabs, where we inject directly through a slab and between the soil layer and the bottom of the slab. Those are two different, real different types of application or methods for injecting polyurethane foam. Common misconception out there is that slab lifting by itself, that is direct injecting between the soil and the slab, will meaningfully improve or stabilize soils underneath. That is I've always taken a little issue with that. It really, if we overcome the weight of the slab on top to lift, we're really not putting any more weight on the soil below. So unless there's very sandy, silty soils, even wet soils, we can encapsulate some of that with slab lifting. But we're not really improving soil density and bearing capacity with typical slab lifting. Now, polyurethane foam, because it it goes in as a liquid and then changes to a solid over a set amount of time, whether it's a fast or slow or medium speed foam. There's two forms of spread then, because the chemical is reacting as it's moving and being injected. That initial chemical state, is going to, or liquid state is going to allow the foam to soak in to those, or the chemical to soak into those soils that it's able to penetrate. It is a little higher viscosity. That's one thing I didn't mention with the earlier slides. Single component systems are typically designed to be lower viscosity. Dual component lifting systems are typically designed with a higher viscosity. So that saturation isn't going to be as much as you might find with a low viscosity single component system, but the rapid expansion is going to account for that in our stabilization as well. And because it goes in as a liquid and it's rapidly expanding in a confined environment, it expands into voids, expands and pressurizes around the injection point. But then once that path of least resistance, it's going to spread out sideways, typically down, up, but we're not going to see any lift or any movement at the surface until all the void has been filled, the soil in that immediate area where we're injecting has been densified. And then we're going to see the path of least resistance is always going to be up. All right, so with those ideas out of the way, and just some base knowledge, I want to talk about some engineering design with deep soil injection. The number one idea to think of here is it's an in situ structural restoration and construction. So we're able to, with minimal access point, the probe rods that we typically use, like, as I mentioned, 1/2 inch ID. And so you've got a very small entry point for the tubing to be injected or to be set down into the soil. And so that in situ structural restoration construction, that idea is that we don't have to dig. So not much excavation to make that happen. When it's in compression or confinement, that path of least resistance, and that liquid state of expansion is going to, like I said, encapsulate some of the local soils right around it, but then it's going to rapidly expand, and it's going to compress the soils as well. That will have a limitation. I mean, obviously, it's not going to compress. It's going to compress to a certain degree. So then we need to start looking at how often we need to place our injection points, and we'll talk about that here in a minute. So a little bit more on the soil interaction. The polyurethane foam, I used to think of it as when you inject it underground and at the end of a tube, I used to think of it as a sort of a ball, of foam, and that is not at all what it tends to look like underground. There's been many times this has been excavated and looked at, and it's very clear that it is a product of opportunity. So it will always take that path of least resistance first. So we're typically not going to have big wads of foam unless we have a void that it's filling up. But as it expands and compacts the soil around it, it finds those tiny little fissures and it lenses. It becomes, you may have some pretty thin layers of polyurethane there, but that thin layer of polyurethane forced its way through, a pretty tight layer of soil in it, and compacted and encapsulated some of that as it went through. So for deep injection, if as we inject the polyurethane, how do I use a pointer on here? All right, I'm not gonna worry about that. But so for deep injection,
it actually showed up, Kevin, if you want to use it.
Oh, did it? Okay. So for deep injection on this side here, what we're looking at is the initial injection of polyurethane. We've got 3 separate levels of injection, 3 different tubes of different lengths. And then we're seeing that as the liquid encapsulates that or starts to soak into the soil, you get basically a shell of poly and soil together. And then it consolidates as it continues to expand and sets up, and the polyurethane cures. Then we get to that final stage. So for an injection design, it's going to be goal based, of course. Are we looking at load bearing, trying to increase load bearing? Are we doing a water stop application such as a grout curtain? Is this a void fill? There are as many different injection designs as there are geological conditions that you inject into. Now they're pretty common standards and accepted norms, but there's a lot that goes into designing a proper injection technique for this. So a typical injection design, as I mentioned earlier, we go typically 3 to 5 feet on that vertical as well as horizontal spacing. On the 3 foot, if we're at 3 foot intervals, we're going to increase the material density. We're getting closer together with our injections, and so we're getting more, maybe possibly more interlocking between the different injection points, as well as the densification of from one column to the next. They're pushing on each other. And then, of course, we can get into designs where we're actually, basically creating a box first and then injecting in the center, so that we've already got confinement around that area and injecting into the center as well. So tighter increments, we're going to increase the material density because we're closer together. So the adjoining, after we inject our first location, the next location, then the third, then the fourth, those start working with each other and against each other to help increase the density of the soil. At a greater spacing, of course, still provide good soil density, but maybe a little more permeability of the soil, assuming it's a permeable soil to begin with. So looser increments, we don't have, there may not be as interlocking with our, in foam injection points, but we can still get a very good soil density increase from that. So sticking with that grid is very important with deep soil injection. A gridded pattern is going to ensure that we don't leave out areas of soil and leave them untouched by the chemical or by the effects of the chemical, I should say, the expansion of the chemical. A grid pattern, we've mentioned the top, the vertical and horizontal grid, but sticking with that is very important with deep soil injection. And so as we get into that 3D grid and see how it all densifies the soil, this is a pretty good depiction of what I imagine a lot of it looks like underground, as we inject the chemical. But of course, things are going to differ very greatly out in the field. Now to look at a grid. And you can see the stabilization that can occur by injecting this at different levels, at different depths. It can be substantial. And, grout curtain walls, if we needed to stop water flowing through underground soils, an in situ grout curtain wall is one of the options for using deep soil injection. In this case, we're not necessarily looking for, a surface bump, although I would be typically, but we're trying to densify the soils at depth and stop water moving through the soils. You can use an offset grid pattern, running W, running V type formation. Maximize your coverage through these offset grid patterns, as we various ways to design that. But again, the coverage is what we're gunning for, and it's all going to depend on how close together, how far apart our injections are. There's many factors that go into deciding how far apart, but the main ones are, of course, the speed of the chemical, how fast it reacts, how long it stays liquid before it begins to react, and then how far it's going to travel. Somewhat the density of the chemical as well, and of course, what type of soil we're injecting into. Another in situ design we can effect with deep injection is a bridging design. This was there was a project that I had here. I'm in Hot Springs, Arkansas, and had a project in Arkansas that where we bridged a certain under a road in order to go over a structure that was there. So being able to distribute the load and have a bridging effect is possible with this as well. And of course, subgrade infrastructure, injecting through a tube. Now, in a lot of cases, this is more water stop than soil densification, but we can the same chemical that we use to stabilize soils can also be used to stop water from entering a pipe, manhole, you name it. And temporary shoring. Temporary shoring can be done in situ by pre-injecting along the line of excavation with the right chemical, and then excavating down, and then pre-injecting again for the next bench level. So temporary shoring can be accomplished with this as well, and it's been very effective. The process of deep injection, accepted industry practice has always been top-down injections. And the original idea was designed as a top-down approach. That was so that we always maintain contact with the surface. As I mentioned before, we measure with a laser level, some other type of device that'll measure that, typically a laser, and we're going to inject top down. And so I'm going to inject the top level first. I'm going to watch for a movement at the surface, and once I get my movement, the amount of movement I want, then I move down to the next level down, and I get my movement from that level of injections. Now, bottom up injections, very common with a single component type application, and it's also common with deep injection with dual components chemicals. However, there is, because of the expansive nature of the dual component chemical, it is best to limit those injections. If you start bottom up, it is best to limit those to a limited quality or timed shot. We don't want to try and sink a 30-foot tube down and try and lift a warehouse from 30 feet down. You could end up with a fracture that allows a lot of pressure to escape very quickly. And so, bottom up, and I've had to do this a couple times where we shot a limited quantity first at our lower level, and then shot on top of that to give us a base to work against. Here in Arkansas, we have a lot of water, and that water tends to play havoc with foundations. So giving ourselves something to lift against was important in some cases. So operations, site prep. First thing, when getting on site, of course, we're going to take pre-elevations. I want to make sure that I know exactly where everything is before I start. But we're going to, one of the main things that you're going to have to think about with in site prep with deep injection is the drilling, driving, and probe rod preparation that you're going to have to do. For those of you who have lifted a driveway or a sidewalk or some type of a slab with polyurethane foam, that's a pretty straightforward and easy process. I mean, I get on site, I drill a hole, and I pop the injector in and begin shooting. It's a little more involved than that, of course, but there's a lot more preparation that goes on the operations side with deep injection. You can see the probe rods there. Those are half inch or 5/8 steel tube. I can't tell. But down below, we have color-coded tubing that's already been driven into the ground, and that color coding, just to point out that it looks a little like PEX because it's red and blue, but it's not. That's steel. Those are steel tubing. But the color coding is so that we know what the depth is. So I mean, once we get the probe rods in the ground, which one is the 5-foot depth and which one is the 8-foot or 10-foot depth. So I need to have color coding at the surface in order to keep track of that. One of the most labor-intensive things you'll have to do is the drilling for deep soil injection, drilling and driving, I should say, because we drill a hole typically, but we're not going to drill for the full depth of the injection tube. We're going to drive it the rest of the way. We need to keep a seal around the outside of the tube as best we can to keep the injected chemical into the ground and not coming up around the annulus between the injection tube and the soil, where we just drop the injection tube through. So want to make sure that we're making sure that we've got all those challenges worked out before we arrive on site. Many times that drilling is going to be done by your own operations people. And there's other times that you may need to have a drilling contractor come out, with that has the capability to do larger holes, deeper holes, that kind of thing. The probe rods that we use typically, as I mentioned, I typically use the steel tubing. I've used copper, off the shelf, PEX off the shelf from Home Depot or Lowe's in the past. Don't recommend trying to use thin-walled, conduit or PVC, as the chemical reaction of the polyurethane foam is an exothermic reaction. It gives off heat during that process. So PVC can be affected by that and then weaken it. And of course, conduit, we've got, we're working with some pretty high pressures, and so conduit's not going to hold up very well. But the probe rods, varying types. We do have different types that we recommend, and you can contact us for that as well. Contact your local representative, NCFI representative. Some of the tools, specialized type tools, tube taps, or a packer injector that's screwed into the top of a tube, that works. We have compression fittings as well to connect the guns, and driving tips. Now, all of these are optional. They're typical that we would recommend here at NCFI Geotechnical, but they are optional. I mean, in place of a trout tip at the end of your probe rod, I mean, if you're using PEX, if you're trying to drive PEX down 6 feet, that's not going to work. So I need to have some type of a solid rod down the center of the PEX, and I can do that with a copper tube or even a steel tube. And use a driving rod that pokes out the bottom. The main function of that tip is to keep, soil from getting up in there and plugging it and having it, trying to inject and it blow back at the operator who's injecting. So there's varying options for, for these, but these are the most common. Driving the probe rods. So I'm trying to minimize okay, I can't see my screen. Driving the probe rods, typically use a ground rod adapter with a hammer drill. The bigger hammer drills, we had a Hilti TE60, TE70, but there's a ground rod adapter you can put on the end of those. It's got a socket and the tube fits inside it, and use just the hammer action of the drill to drive it down into the ground. And so, that's for single tube injections. You may be doing multiple levels with a single tube injection, but you're still driving one tube at a time. If there are multiple levels, if you have multiple tubes, you might have extra tubes that you bundle up with others, just in case, what happens if one of the tips comes off, and you have a tube that's plugged, or what happens if you have an equipment problem in the middle of injecting down a tube. Well, in that case, you've lost that tube. The tubes and tips are sacrificial. The tubes can be pulled, but tips are gone. But if I lose a tube, if it fills up with foam before I'm finished injecting at that level, I need to have another tube ready to go to inject that same point at that same level. So you might drill larger diameter holes and bundle bundle that information. Sorry, not information. Bundle the tubes together and set them down all at once. Getting rid of the tip at the bottom. We use a tip knocker to do that, just a piece of rebar. So that tip is there to drive. I can just drive with steel tubing. The reason I really like the steel tubing is because I can drive the steel without having a rod inside it. Just put a tip on the end, and we're headed down and begin injecting the polyurethane. And then once that tip is released and we begin injecting, that's when we start to see the lensing and the expansion of the foam into the soil and saturation of the soil around it. So for quality control, we mentioned laser levels, but there are other things. How do I know how much chemical I'm putting in at a time? There are the proportioner pumps that we use to properly heat, pressurize, and mix the polyurethane foam, the chemicals that make the polyurethane foam together. They have a click counter on the pump. That click counter relates to how many fractions of a gallon are put out by that pump with each pump cycle. So we can look at that and we can calculate based off of how many gallons we put in the ground. We can calculate back to the number of pounds. We can also use flow meters, inline flow meters. But if you've got a time shot or a certain amount of chemical that you need to put in, that's going to be very important. Of course, usage is, how much have I used? How much should this project cost me? How much did I make? That kind of thing is all done based on that information as well. Surface measuring devices, we talked about the laser levels, but subsurface measuring, there are dynamic cone penetrometers, very similar to they have a similar result to a standard penetration test that you might have a geotechnical engineer do. DCP, dynamic cone penetrometers, those are available to an operator could use it themselves, not to generate any kind of a report or so much as really just trying to find that level that we want to target, the depth that we want to target with our injections. So subsurface measuring with a DCP, there have also been talk about using other techniques to do that as well. But that's being done out there. Our polyurethane processing equipment, on the equipment side, you need to make sure that you have that your equipment can handle the back pressures that are going to be generated. The deeper you go, the harder you have to push to get it in the ground. So those back pressures, you need a high enough pressure machine or flow machine, not necessarily pressure, to get that chemical down in the ground. Crew size is going to be a big factor in quality control as well. 2 people minimum, but I always preferred 3 to 4 on a deep injection project that's going to be more than just a few injections. We need people that are going to be able to be monitoring back at the rig. Need people that are monitoring lift around the area being injected, and so don't try and do it with too few people on a crew. So that for quality control, the person that's actually on the injection gun that's injecting a chemical, that person should be your most experienced, because they're using all their senses really to in addition to the measurement that we're doing, but using all their senses to know what's happening as the chemical goes through into the ground. So they need to know what's happening at that injection gun as well. So some projects that have been done with deep injection. This one. So in this case, we've got a tilt-up footer, retaining wall and drive lane that was stabilized using deep injection. In this instance, we had a 30-foot CMU wall, block retaining wall. The contractor used 50,000 pounds of chemical, drilling 133 holes up to 50 feet deep. So injected both interior and exterior, stabilizing everything, the areas that were injected, down to 50 feet. So as confirmed by the engineers on this project, settlement was, ceased. And it took 14 days with a 2-man team to do this particular project. So obviously, depending on the size of the project, you may have all kinds of equipment that's necessary to have with you on the project. So in this case, we've got a man lift, and that's to get I'm pretty sure they were driving 20-foot sticks, from that man lift up above. Ohio State University, indoor track stabilization. It's done by Ohio contractor, Mr. Level. So this was a neat one. The indoor track needed to be stabilized. They used 2 different systems, Polyurethanes 24-010, which is a fast system. So for the shallower injections, and Stratafill, our Stratafill line 24039, which is a very slow system. It's also hydrophobic to stabilize soils. And the main reason they used that one, I believe, was to make sure that they didn't get as much expansion out of it, and to try and keep from lifting the track itself. But again, proper monitoring at the surface of the track would make sure that, ensure that you're not lifting that as well. On this particular project, they estimated over $900,000 in savings, with and they stabilized 2,000 square feet of track in just 4 days. The process can be very quick, and it can certainly, because of the low project footprint, the small project footprint, the small point of entry. This can be done in areas that it's really difficult or much more costly to provide a solution with other measures. Rather than having to take up the track or rebuild it. In this case, they were able to save a lot of money and time by injecting using deep injection. This was a CIPP excavation support. Had a lot of gravel pouring in. This looks a lot like how we do it in Arkansas. We have a fill product that it's a great fill product here in Arkansas, but it's made of flaky byproduct from shale processing, and it's great for a fill inside of under a slab, but it's really horrible to try and dig through. It tends to collapse in on itself. So for that supportive excavation, temporary supportive excavation, it can be the soil, or in this case, pea gravel, can be injected with polyurethane foam prior to excavation to give the stability that's needed in certain circumstances. Something else to look at on the images you see here is just how tight an area we can work in with this type of approach. So we've got a lot going on around the injection area, and then a lot going on in the injection area as well. Bottling plant with Utility Services Group. This one was Polyurethanes 24003, which is a 4-pound system. They were densifying soils in this bottling plant through 180 injection points. As you can see, a lot of accessibility issues here with all the equipment, and in many instances, we don't have to move, or our contractors don't have to move equipment, and can oftentimes work around it, with that tight access space. you know, trying to go 50 feet inside, you know, inside a residence, 50 feet deep inside a, you know, a 8-foot tall ceiling. That is possible, but we would have to be, you know, sectioning those tubes together. In this case, looks like they had plenty of room. But also, this was all done during off hours, and the plant stayed operational through the process of the repair. And then footing stabilization. This is a 2-story addition on a elementary school building. The footing was, you know, up roughly 3 to 4 feet below grade. Had a narrow spread footing that needed to be supported, and so this was a deep injection application. The goal was to get get our chemical directly underneath the center line of that wall. So if I have a center line of the wall here, I wanted that chemical somewhere directly below that center line as much as I could for that. So we calculated that angles, calculated the angle from, and we used the interior slab on this. The exterior of this building was, of course, elevation changes. Doing it from the interior made it a lot easier. All of our tubing was the same length. The angles were all the same length, so that we could get to the proper location directly beneath that footing. Now, the picture on the right, I'm not going to try and do a video here, but on this, that picture on the right was actually, it looks like it's just a mound of foam, but what you're seeing is the actual length of tubing that we were using, and we were turning the heats up to get our chemical to react as quickly as we could get it to react as it was coming out of the tube. We didn't want it to spread further. You know, we wanted to minimize how far the chemical spread underground side to side, and we wanted it to kind of bunch up and get that confinement quickly, rather than soaking, you know, lensing and soaking further out. I wanted it to get a lot more quick expansion to stabilize that right there. Using a laser level, and then we use tape to mark the drive depth for each of these injection rods. And you can see that we're using the angles there, angle finder, making sure that we're getting, and then we drive the tube down to the tape mark. And it's just a, you know, an assembling line process at that point, with enough people working on that project. And that, you know, the whole project was accomplished within 3 days, I believe, on site, to get all this, the entire addition of this building stabilized. We used 2 guns shooting at once in this case. Of course, if you think about, you know, trying to spread the load, whether you're, I'm used to talking to people that do foundation contracting, and so I was going to mention something about piers, but I'm not. But as you try and spread the load, you know, the further you can, the bigger a spread you can get. You know, you tend to use less material, and you tend to get an easier lift. So we used 2 guns on this one, and had the laser receivers stuck on the wall and watched it move up. And you can hear the fast beep as it starts to move through the shooting. Robert, how are we doing on time?
Not well. We're at 10:58 at the moment.
Okay.
Or excuse me, 12:58, depending on where you're at.
Okay.
So 2 minutes.
I'm really at the end. I
Okay.
did want to mention, you know, this is the kind of the final thing I was going to point out. But this was the project. I mentioned that we had to do a bottom-up injection at one point to build a base. This was that project. It was a it was a lot of water. This is Arkansas for you. And there was a lot of water down, sitting on top of hard shale. In this particular case, we actually went out one weekend and worked at this location. We lifted it. This was when I had my contracting business. And we lifted, everything looked great. When we left, we came back the next week and it had settled again. And what we found was that we had gotten through some head scratching, found that we had gotten hydrostatic lift. We pressured up a bunch of water, and then over the week that we were gone, we that water pressure dissipated. And so when we came back the next weekend and found that it had settled again, that's when we went back to that bottom up approach. But it was a prescribed amount of chemical that we put in. And that's key, is that we weren't trying to lift from the bottom of this pit filled with water. We were simply trying to give the water enough pressure and get it out of the way so that we could lift properly where we needed to. And I think we're at the end, aren't we?
That we are.
All right. Well, thank you very much for attending. I really appreciate the opportunity to do this. But thank you all for attending.
Well, y'all don't go anywhere yet.
If you have
if you
don't go anywhere.
Yes. Okay. So, if you can switch to the next slide, Kevin.
Yeah. Is there another one? I don't think I have another one.
Oh, well, I guess it didn't update in the newest version.
Yeah, I don't know. I skipped that.
All right, that works for me. So remember the Q&A box? Answer questions down there, click Q&A, ask question, and send. And then Kevin, if you want to just move it to your slide there so people have your information available. And then we'll go ahead and start with the Q&A, which, by the way, the prep to, ask questions throughout the meeting was quite successful. So I want to thank you all out there for, really getting on and asking your questions. So the first question is, this was a bit answered, but I'm, going to address it again, is what are your thoughts on lifting structural footings using the deep injection method?
It's not for the faint of heart. Standard residential footings, not quite the same issue, but it is as you get into deep injection and lifting footings, it is a highly specialized field, and there is a lot of information out there that's not really available, I guess. Except in institutional type knowledge, like we have here with our team at NCFI Geotechnical. So yeah, I mean, it's certainly being done, and it's a great application, but it's as you get to larger structures, it becomes a really specialized field.
Yeah, and I mean, I would add on to that, there are companies that their entire business strategy and service is around stabilizing footings and column structural supports. So it is a great application for it, especially in stabilization. But as Kevin mentioned, it's not something you want to just go do tomorrow. So unless you've got a good resume prior to that. Next question we have is, often having trouble lifting concrete steps. The question is whether or not these 4 or 6 pounds, something higher rated. I'm assuming they're using something like a 2.3 or something like that. Do you think it's a pounds issue? Do you think it might be an ejection approach issue? I know it's hard to say, but
with steps,
we'll put it out there.
Yeah, I mean, with steps, it's my opinion is, and what I've experienced is, it's typically it's just a physics issue. You've got the steps at an angle. You've got kind of forces that are pushing in weird directions, and then you've got all kinds of different construction methods when you talk about steps too. We were trying to lift some stairs once. It was actually here in Hot Springs, as a matter of fact, and we had a problem because it was with the stem wall on the backside of the steps. That can be an issue, but that's because of that that force that we're trying to lift. Just with foam in that case, I would probably look at some kind of a jack in addition to the foam. You know, I mean, I can use a jack in that case, and then I don't think it's a deep injection issue though. In most cases, I wouldn't think, at least in my experience.
Yeah, I mean, well, and I guess the question was really relating to, foam density, was what their concern was, is that they're not using a high enough foam density. I'm not sure if it was around whether deep injection was an appropriate
Yeah.
approach or not. So,
Okay.
um, I mean, at the core is it's like I've seen stairs be lifted utilizing just method injection right underneath, right? But when you have problematic soils at depth, utilizing a deep injection in that instance would make a lot of sense, right? Because
Mhm.
you're doing stabilization
Yeah.
at depth.
But as
Um,
we could, on the density issue, just real quick. I mean, I can lift, you know, I know with my business, we lifted 72 tons with a 2.5 pound foam. So
are you putting all the rods down at once or drilling through the foam to drive the next rod?
all down at once. Don't like to have to try and get back through that foam.
Yeah.
I've got video of somebody trying jackhammering back through some of our NCFI 24003, and the only way they could get through it was with a jackhammer.
Yeah, I mean, the only times I've ever seen where they've tried to go through the foam and post was it was either a mistake or a misevaluation of what was going on in the soil conditions. So,
Yeah, or you burn a tube and you don't have an extra. That's the worst is trying to get you know you didn't sink enough extra tubes down, and now you've got you've lost a tube because it filled up with foam or whatever, and now you have to get back down to it. So yeah, that becomes an operational issue.
this was discussed, but I think it's worth covering again is how do you evaluate the strength increase of the soil after injection?
So there are a number of ways to do that. The the idea of being able to measure at the surface, and maintaining that contact with the surface, that idea was when they came up with that idea, that was a really easy way to verify that we have densification of soils and void filling of soils in that immediate area. It works. I mean, it's proof positive. If I inject enough chemical into the ground, and I get that bump at the surface, I know that I filled, at least within the radius of typical expansion for that system that I'm using in that particular soil. I know, since I've got that bump at the surface, I know that it's working. Now there are additional methods. The dynamic cone penetrometer can be used in pre as well as in post applications. So you can, check with that. Use the DCP and compare the pre and post numbers. The thing is with unless your grid pattern's tight enough, you can miss it with an 1.5 inch, diameter test head. So you may have a good load spreading, situation that you've created with a deep injection. But then you go and try and, verify that with a small little, cone, and you might miss a spot.
Yeah. And I've seen with some DCPs using an average over a zone in an area to try and come up with a
Mm-hmm.
number. Yeah, but again, like it stated, if you hit you hit kind of like an in-between spot, that cone is going to have a little bit more penetration than normal. And there have also been some jobs that we've seen, in very, very large soil bearing increase projects where they use deflection, but that is
Like a dilatometer.
mhm. Well, or
Yeah.
it's
Oh, they're
using kind
doing
of like,
deflection testing. Yeah.
yeah, yeah. Okay, what formula is generally recommended for soil stabilization?
Formula. Uh, that's a great question.
I think he's
It's
referring to which system, Kevin.
Yeah,
So
system.
system one,
okay. I'm thinking math formula. I'm thinking I really don't. Yeah. So it's difficult to quantify the other. Yeah, formula for soil stabilization. Depending on the soil type, I mean, it really depends on how much flow you think you need. But any of the systems, we typically use what I typically see out there is the 24003. It's a good medium speed foam. It's a 4 pound minimum density, so you've got a 80 psi out of the box, and it's only going to go up from there. So you've got a good range of depths you can get to, because it's a little bit slower than some of our other systems that are designed for more lighter weight lifting. We have a system that's 24-042. That's a 3.5 pound foam. It's a really good system for sort of a deep injection or void filling. But for just general soil stabilization, depending on the depth, you could use the typical stuff you use to lift a driveway with. If you can reach it with that. Now, again, you've got to look at, okay, if I'm using a fast foam and a lower density foam, how deep am I going, and how close together does my grid pattern need to be, in the X and the Y axis? How many depth, how many levels do I need? Those questions are all things we can help you with, and that's what we do. But it's very, very subjective.
Yeah,
To the particular.
site conditions are going to play a major role in that. I
Mm.
mean, even if you have like high water presence, you're going to need a hydrophobic system. It's so the best thing is to reach out to your rep. We've got 40 more questions here, so we've got to probably keep it moving. So we've got how do you install injection tubings? If jetting, can you jet them into dense, stiff soils? Do you abandon them by grouting them in at the end?
You can jet. That's real handy down in sandy soil, types like like you find down in where I came from, where I grew up, down in the Houston, Texas area. Jetting with water is useful. Yes, you can grout them back in place. I've never grouted a rod back in place. They're filled with foam, and they're steel rods, so they're we try and pull them as much as we can. But sometimes it becomes really hard to pull those back out. So there's varying ways to deal with the injection rod in the ground. And of course, as you get to, as you start getting to more machinery based type installations, you can use some of that to help you get it in the ground or back out.
Yeah, but the answer is typically you'd leave the rod in the ground though, right?
Typically, yes.
Yeah. How do you evaluate the reduction in permeability of subsoils in a water stop application? Does injection completely seal off all interstitial space in the soil matrix?
Ideally, yes, it would. And as we know, water, it can be very persistent. But yes, with the correct design and application, you can. I'm not an engineer, interstitial space and that kind of thing. I understand the word, but I don't understand the meaning, maybe in that context so much. But I would say that, proof's in the pudding. We've done many of these, and they hold really well. Do you have
Yeah, and
anything
I
to add to
think
that, Robert?
yeah, I mean, I think talk about the project time. Like, what is the context of the project? If you're going to have a project that has really minimal accessibility or in remote locations, if you have an aggressive timeline occurring in space, sometimes it's an evaluation of cost effectiveness to what you're gaining in speed, right? We've seen projects where they do a lot of hotspot mitigation, where they're stopping contamination movement within construction zones into a semi-shoring and also stopping water flow into those areas. By doing that, they were able to get quick access in a high busy zone, because this was in right along a highway, a highly trafficked highway in the middle of a town. They didn't need to fill it up with a bunch of construction equipment. They were trying to really avoid doing dewatering. And they were also trying to avoid, the environmental issues that was going on with the hotspot. Now, it doesn't have to be that complex, but you have the ability of having something that can adapt to something of that complexity. So it really is an evaluation of what you're trying to achieve and what the project goes overall as far as schedule and cost. So,
Well, and I would say this, in the right soil type, single component grout curtain can be a much, uh, because of the permeability of the single component systems, maybe a better application for that. And so again, that's another part of the evaluation. I mean, if it feels like we're teasing you with a bunch of information and not giving you a lot of details, it's because the details are so subjective in many cases that it's hard to talk generally about some of those things. But yeah, I mean, single component I would look at in that case as well, depending on the soil type.
what is the maximum depth you would consider for deep injection to be effective?
I don't know that I have an answer to that question. I mean, usually we're just limited by, number one, how far down is it really affecting the soil above? And I see Tom just popped up. Did you have an answer to that?
Well, I think the question it's a tough one because it really depends on what we're trying to accomplish, but the soils themselves are going to make a huge difference. Like if it's needed at 50 feet and you can get to that, then you're having an effect, but only if it's needed. I looked at one building that was, the engineers basically said, well, the soils report says it's crappy down to 100 feet. But the reality is that, our engineers said, hey, there's only a zone of influence for this particular structure only weighs so much. It's only going to influence the soils down to about 60 feet. So that's all we really need to treat. So if the soils are bad and they need to be addressed based on the loads and the structure that we're trying to support, if we are trying to support a structure, then you can, as deep as you can get your pipe, we have systems slow enough that we can flow the material down to get to that zone. It's just a matter of whether or not it's really necessary. So I hope that answers that.
Yep.
I mean, it's what's interesting is if you look at Slabjack's project, that was for Slabjack Geotechnical out of Washington State. It's the project where they were doing the tilt-up building. May take you a minute to flow up there, but they, in that instance, they drilled 6-inch holes to get all the way down to 50 feet and then bounded all of the tubing within all the at 5-foot increments going all the way up. And then they were able to, they moved them all the way down through the hole, backfilled it with soil. And then they were able to accomplish 50-foot injections. And I got to say, I've been hearing, from some of the top polyurethanes guys out there that, they're vastly starting to extend the length of their injections, and they're doing that through a variety of techniques. Some of it is through temperature regulation within the poly to offset reaction time. They're using different materials such as PEX to help increase the travel, using some of our systems that have like a slower reactivity time in order to get it down there. So really that needle has been constantly moving, especially over the last 5 years. But I mean, you see here where you got a 50-foot injection that's occurring. Now they're in a little bit cooler temperatures that helps them get that travel. You're not operating in a Florida environment where you're trying to, bound against 90 to 100 degrees to get the material moving in the summer or even in Florida in the winter. So it's a constantly moving needle, correct? And it's all going to depend on what's going on and your specific environmental conditions to allow for it.
And we have systems that run very long times. They're not as typically used for those types of projects, but they can be. So we've got some that run in excess of 5 minutes. So we can get it down there usually.
Okay, I got an interesting. How do you clear the bullet point or the points at the injection at pipes that are 20+ feet deep?
Well, a lot of cases, well, if they're 20 plus feet deep, you can weld a couple of, 1/4 inch rebar pieces together. I've seen there's all kinds of ways you can do it. You could, it's possible even to blow it off with air or water if you can lift up on the pipe a little bit. If you want to make sure that now, if you're 20 feet down, you have a bundle, you're not going to be lifting the whole bundle. But that's, there are various ways to do it. You can get down that far.
Typically, you get the pressure out of the chemical to blow the tip out. It's just a little more comforting if you know it's already pushed out.
Yeah.
You can mechanically move it. But if you back your pipe out a little bit, that helps. And then, like he said, water or air. You really don't want to put water in there if you can avoid it, but air sometimes will blow it out, sure.
Mm-hmm.
When when you're doing deep injection, do you have to worry about exotherm? Foam getting too hot for those in the audience who need to know what that means?
Yes and no. So the exotherm issue is, exothermic chemical reaction gives off heat. The foam is an insulating entity, so R value around 7 per inch. And so if we get a hot core inside there, it can cause that hot core to degrade the foam some. And in worst cases, if it has access to oxygen, occasionally can cause things to smolder around it, or even have a fire. But in that case, no, that's not something that I've been concerned about typically, unless there's if you do hit an unknown void, and it's a big void, you can end up with an exotherm issue. But typically underground, you're not running into those situations. If you hit a pipe, you're gonna know it, and you're filling up a pipe. Your customer or their neighbor is going to be coming out to say, hey, my toilets are stopped up or whatever.
Or smoking.
It's smoking. Exactly.
No, I mean, isn't that kind of the point though, is be aware, right?
Yeah.
I mean, if you're in an injection situation and you just got way more material moving than what you were accounting for in the void, and you're just injecting all day long without getting any kind of bump or movement, then you might be aware that there might be something happening. And there's injection techniques you can use to try and mitigate that from occurring, such as short shots allowing to cure it and do an injection, et cetera, et cetera, et cetera, right? But be aware of what's happening. And it can happen. I've heard situations where company had to go back because a manhole was pretty much smoke was coming out of a manhole zone where they had treated, and the reason why is they had travel inside of the manhole, just kept injecting all day long, and then you've got a smoking manhole going on. So just be aware of the situation occurring on the site, right? So
yeah, it's always something that you need to be aware of. Absolutely.
All right. We still got quite a few. And by the way, if we do not get to your questions, we will certainly try to either answer it through the chat or follow up with you. So we've got, forgive me, I'm going to drop down and get one here. How do you check soil density or void size to figure out how much foam is needed to stabilize?
So the DCP or a geotechnical report will give you some of that information. A lot of it, there are people that are working on ways to quantify, that what's the word I understood earlier but didn't know it's used very well. But anyway, the space that's between particles of soil, I don't know what you call that, but can't think of that word right now. But all that said, you can calculate, or geotechnical engineer, someone with that knowledge can calculate, that information. What we typically did was we went for an average, an average take per injection point. So with experience, at first our averages were a lot higher, I might need 20 pounds of chemical, and I might have scoped 100 pounds. You know, and over time though, we got a lot more experienced and we became able to, you know, get that quite a bit closer. But that's always the, you know, the 1,000-pound gorilla in the room is how much is it going to take? And so, you know, quantifying that, you use all the information that you have, you know, at your disposal. And that means that you need more information than a typical project. I mean, you know, a deep injection project, you're going to need geotechnical information. You know, if you're going beyond 5 feet, you know, just to try and stabilize the, you know, the corner of a house, you know, if you're going 50 feet to stabilize a building up, you know, like we're still looking at here, that's a real different calculation.
I got an excellent tip, and that was actually from Jerry Sargent from Slabjack Geotechnical that did this project on the screen, was that you can actually notch those really deep pipes out rather than knocking the tip out.
Oh yeah. Yeah.
Yeah.
Perforated, kind of like a tributary.
Yeah, or at
like
least at the ends, being able to provide some
tube
notches for escape. Yeah, excellent tip,
Yeah.
Jerry. Thank you so much.
Yeah, that's great. Like a tube of manchette. Yeah.
Yeah, 2-inch shed, not trimming tube.
Yeah.
Sorry, on terminology there.
Yeah.
So this kind of fits together. Man, so many great questions in here. What kind of soil types do you find that this is successful in, and what kind of soils would you find to be a challenge?
Clay's always a challenge, you know, for everything. Deep injection with dual component foam works in clay, as long as you can get the, you know, the clay to take it. I mean, we're not gonna permeate the clay particles with the chemical like we would, you know, in a sandy environment, you know, or pea gravel, something like that. So you have to fracture it, and you know, that can lead to, you know, in one case, for instance, it was here in Arkansas, in Mena, Arkansas. We had clay that we were injecting into, and a fracture opened up, and what it did is it opened up all the way to the surface. We were down about, you know, 15 feet or so, and it opened up all the way to the surface. But where that fracture opened up was underneath in the crawl space of the building we were working on. And so we ended up with a, you know, a twin bed size mound of foam before we, you know, realized what was happening. So there's things like that you need to work on, you know, or be aware of. I am not aware of any soil that we would say no. Tom or Robert, you heard of?
Not necessarily. I mean, what we have to look at is the actual soils reports and determine, you know, is it viable? You know, you're not going to get foam to expand into, you know, 30 blow count material. We're looking for kind of weight of hammer. A good rule is kind of that single digit weight of hammer to 9 blow count material. Doesn't matter what material it is. If it's that soft, it can be pushed by the expansion of the foam. And you start getting into the double digits, becomes less viable. The higher that number gets, the less likely you're gonna. But also, the higher number that gets, the less need there is for it, right? So at a certain point, you know, 30 blow count material is great material. You're not going to need to improve that soil, but it does have its limitations. It's not going to be, you know, great in a 15 blow count material. It's going to be tough to get much in, but you can still do it. It's just a matter of it being a little more difficult to get as much in, and it's going to pack in a lot denser, so you're going to get a lot more material to get to see significant improvement.
I mean, as far as a no on material, I would just say maybe a no at the timing. You know, you start getting expansive clays that are really saturated. You probably want to be really careful about treating those, especially in an expanse, or clays that have really retracted. You know, you start putting a bunch of material down in there, that clay does come through an expansive process, you might have a problem. So that's all I would say. I actually really like this question a lot. If a deep injection behaves in a heterogeneous way, looking a little like an anthill almost, then can a grout curtain really be watertight? Does a grout curtain require a secondary grouting with a single component grout if you want it to be truly watertight?
It certainly can't hurt. It's, I know that in certain places it is somewhat standard practice to use both a dual and a single component for water stop. The having the capability, and of course, as a manufacturer, having the expertise on staff to be able to do both, helps us in that area. But no, typically, I mean, the grout curtains I've seen have been, one or the other, most of the time. And is it the foam doesn't have to, we're not trying to replace all the we're not trying to get foam inside every bit of soil. What we're trying to do is allow the foam to get into the soil it can get to, and then it's pushing the rest of it and compressing it and giving that soil its density back. Now, if it's a water soluble soil, of course, eventually that may start to leak in, and you may need to put some different chemical back down in.
That was a really good answer to that question, Kevin. I like that.
Thank you.
I
Googled it.
I mean, that's the main point, right? And it's the main point of stabilization as well. Gridded patterns may have some sort of layers in between, but it's really still compacting and compressing those soils.
Mm-hmm.
The more you're doing as far as your grid pattern, from a horizontal grid pattern, that X and Y scenario, the more saturation you're going to get, the more compression you're going to get between your individual the grout columns. So it can really create a watertight seal that's heavy. But again, soil types can play a factor in that. So that's great.
Well, and even in that circumstance, if I were doing a grout curtain with dual component foam, I mean, I'd still be injecting top down and looking, for my bump at the surface. I'd be monitoring, because that does prove to me that I've at least in that general area, I've at least made the path of least resistance, filled all the other paths of least resistance until the last path of least resistance is up.
Yes. Okay, so by the way, we were at 30 minutes over, and we're still at pretty good half of the attendees that came on. So thank you all. So I just want to put that out there. Let me put a couple admin things real quick. We will get, somebody asked if we'll get a copy of this presentation. Yes, you will receive an email post that will send you the copy of the presentation as well as the webinar video recording. So if you have others that you want to show it to, it is available. I should have mentioned this 30 minutes ago, so I apologize. But if you are seeking a PDH, when the webinar does finish, there will be an email sent that will have a link to a survey. You need to fill out that survey and request the PDH certificate, and it will come to you automatically. If you have any problems with that, let me know. My information will be on that email. Okay, so answered that. Forgive me, I should have been already prepped there. What precautions would void filling under asphalt?
You need to be deep enough. You can lift asphalt. You don't have to just void fill, but you can't lift the asphalt itself. You have to lift the soil, underneath the asphalt. And so you need to make sure that you're deep enough in a circumstance where you have a non-structural, topping covering over what you're injecting. And so just make sure you're deep enough. It's usually, 3 to 5 feet for lifting asphalt. You might get away with 2, but I'd be looking at, average of 4 feet.
I'll go ahead and answer this one really quick. What do you do with the tubes when done? Pull them or push them down? Typically, you're going to abandon them, but you should cut them at even on the surface. And a lot of contractors use like a type of grout or something at the surface to help cover them up so they're not an aesthetic issue.
And I would make one comment that on a, if you've got an active drive lane or roadway, you got to get rid of those steel tubes, for the first few inches, because it's going to be, they very likely, well, the road is going to move and continue to move a little bit. Whether it settles or not is different, but those rods tend to work their way out and start cutting tires.
Yeah, you can have problems with freeze thaw cycles pushing the pipes back up if there's not enough overburden to hold them down. So if it's in concrete, typically it's going to be locked in. I like to try and just take a crappy old drill bit and put it in hammer mode and push it down as far as I can get it to go down. That'll help keep it from being an issue. But if you were doing one where there's literally no concrete or even asphalt, which is a rarer job, but it happens, like in a curtain wall situation, the freeze thaw can actually start to push those pipes back up out of the ground. So try to get them down deep enough. Can. A lot of times they'll be locked in, but sometimes they can creep back up on you.
Yeah, and Jeremy, Pierce, a concrete bit will help drill out the steel tubing if not available to get out. A good comment. Thank you. If the contractor accidentally excavates too much below the footing, can they backfill it with polyurethane, then cut it back to grade after it's swelled, assuming column footing, asking to see if the foam itself is strong enough to support the footing?
Well, the foam is going to be stronger than the dirt in most cases, but it's not the easiest thing to cut into with a piece of equipment. It's got great tensile strength and great shear strength. So if you're trying to use a bucket on an excavator to dig down beside it, or beside the structure or whatever, and you've got foam in the way, you're going to want to cut it to try and get it out of there. You'll start pulling on the whole mass, and potentially pulling the whole mass out from underneath the footing if you used an excavator to try and excavate down beside it. But the short answer is yes. You just got to be careful how you're doing it. But there's quite a few, foundation repair contractors out there that do push piers and helical piers and micropiles and stuff. And once they've lifted a structure, they'll use the polyurethane to fill underneath the footing, fill any voids that have formed underneath the slab that's inside of the structure. It's a great fill material for those. If you've lifted a structure, you essentially created a void in doing so. And yes, those piers are designed to carry that load over the distance, but it's really good insurance to try and reduce that by placing something in it. And it's really tough to get fill back up underneath there. So you can spread that load out a lot better if you fill it with something like this.
So I've got a question that's kind of marketing. So I'll if you don't mind, I'll kind of address that one. So by the way, I help do marketing for the NCFI side, and it's talks about how do you market in order to get leads for work at larger projects rather than residential. I'll keep this really short. Really the main thing, you can still build up your SEO on your website, work through that path, try and build up SEO articles. It's more of like a long play within the website. What I would really recommend is, try and build and develop lists to do outbound email campaigns to reach out directly to them. Try and build up a library of case studies, a library of project examples that show your capability and capacity. Contact your NCFI rep to help support you out in the field as far as lunch and learns and things along that lines. LinkedIn is a great spot as well to do some networking and to try and present, these, relatively complex or new ideas as far as grouting is concerned to those audiences. Those are a few different ideas that I'd recommend. So, but I would recommend Holly is pounding the pavement is very important. Get out there, try and get your lunch and learns, try and take advantage of trade associations and such. And, those are really great to build up a commercial profile. Those are probably my top tips. So what methods do you use to estimate how much material to use per pipe per area? I would say per injection location.
How much chemical?
How much chemical? Yeah.
Okay, yeah. I mean, good rule of thumb, at least in my area that we found was, between 30 and 70 pounds per injection level. But that's going to vary greatly depending on, your depth. And I mean, most deep injection at this point isn't going past, 15 feet, let alone 20. I would venture to say that that's my opinion, from what I know. So this 50-foot injection that Jerry did, pretty cool stuff. But I lost the question. I glanced at one of these other questions and I lost my answer.
Well, I mean, it was about injection per rod, right? Or per injection point in
Oh yeah. So
material.
20 in my area, it was 20 to 70 pounds. I mean, we would depending on the type of soil and what our weight was in application, we got it down to roughly that. And then, when we would go to shoot, some of them would take 5 pounds and some of them would take 250 pounds,
Yeah, I mean, your soil report, you got to, do the investigation, your soil reports, your DCP tests, what you're, estimating as your approximate voids, what you're estimating as your approximate soil density, what your soil type is going on. Do you have any subgrade structures that could potentially eat the material? Those are some of the things you got to be really perceptive about, or, and try and do, your preliminary investigations. So,
Yep.
Oh, okay. Well, I mean, so this has got some similarities to what's been asked, but I like it. Can the foam be used to lift a structural lightweight concrete slab roadway floating in a marsh over 30 feet of muck?
Floating.
Doesn't state, just says structural lightweight concrete slab roadway.
Yeah, I mean, let's put it this way. My issue would be that you'd need something to push against, right? I mean, if it's currently, maybe it's settling, but it's over a lot of muck. I mean, obviously the road held for a while, or I would think. We can create a mat underneath it of foam and give it some more life, I would imagine. It's hard to say with some of these things being so subjective, but in my imagination, yeah, absolutely. I mean, that was I'd
Kevin,
love to
what
look
about
at the project.
what about the bridging design? Look at the
I
bridging
thought about
design.
that.
Yeah, so
Yeah.
if you're able to move to that slide relatively quickly, I think
Oh
it's
yeah.
pretty deep in there. But I mean, you can talk about different injection ideas, right? Instead of going from the inside out, you build your bridge on the outward and build it in, and it might be a way to create a stable exterior base to build off of.
Mm-hmm. There you go. On my screen, you guys don't see all the questions and all that stuff, do
No,
you?
all we see is load
Okay.
distribution in
Good.
this slide.
Good.
So
it's
does the amount of
it's
water
real
affect
busy on my screen.
does the amount of water affect the strength of the foam?
Not if it's a hydrophobic chemical, and now with one slight caveat. It is at least at NCFI we use the GTP9 test to determine whether how hydrophobic our chemical is. And hydrophobic means that it's going to the chemical is going to set up, it's going to react properly with the characteristics that we display on our technical data sheet, whether it's in water or not in water. So it only applies, hydrophobic only applies during the chemical reaction. I've seen other, and in fact, myself, I misunderstood that when I first started with chemical in 2006. So foam will absorb water, right? It's got cells in it. Those cells are made by bubbles that are let off during the chemical reaction, and then the polyols harden around that, give it its structure. So if you cut those cells, or there are, we certify we're 90% or better, closed cell chemical, depending on which system you're looking at. But if you open those cells up, they're going to absorb water. You know, and eventually you know, in some membranes, you know, the water is going to pass through completely at some point. If it's completely saturated. Now that, again, that's a chemist question, not for me, but don't rail me on that one. But the once it's set up, you know, that's not going to make any difference at all. There's a different calculation as to how much water it might absorb once the chemical is reacted.
Is it possible to know the pressure when using a box with dimensions of 0.7, 0.07, 0.45 centimeter?
And I saw that question, and I'm not sure I really understand it, but
I mean, you would know the pressure in a free rise situation, right? But not necessarily with soil density. Or specific, we would need to know the specific soil type and such.
I took it to mean, you know, our pressure question, you know, how much pressure can it generate, you know? I took it to be one of those, you know, can we measure that? And I've seen people, you know, attempt to measure that. I don't know that we've measured how much pressure the chemical generates during expansion. Do we have anything? I don't think so. And I don't think that, and by we, I mean the industry. Maybe somebody does.
I've heard varying numbers, and so I'm skeptical as to blurt anything out because I've heard so many different numbers. I've heard numbers, you know, 5 to 10 psi of expansive strength, but I've also heard some greater numbers. Each system is a little bit different in how it expands, the rate it expands. The density could have some influence on that. So it's not something that's necessarily easy to measure. We have that data, but that's why we, you know, say that you want to be using this product in soils that are, you know, soft enough that we're having a true effect. You know, you could shoot this stuff into extremely compacted soils, and you could turn it into a bowling ball. It would become so dense, you know. But you're not really having a good effect there. But there's not a great answer. Around 5 to 10, maybe 15 psi of expansive pressure in those soil conditions.
Do you mean one compound? Because I want to treat the soil liquefaction process. What is this compound? So that, I mean, the short answer to that is there's not a specific compound. I mean, go ahead. How about just talk about liquefaction? Because we didn't really discuss liquefaction here.
I'm aware that polyurethane can be used to mitigate soil liquefaction. I'm aware that that's the case. I haven't been involved in any projects like that myself. You know, not specifically for that application. So, anybody else?
I've worked with some folks on this, and I know Robert has as well. You know, some of the engineers that I know were asked to kind of give their opinion on whether or not it works. It can be effective. The biggest area I see it being, you know, used is in post-construction. Now, there's a lot of cheaper methods for pre-construction for that, but once you've built the building, it becomes very difficult to install those types of solutions like wick drains and things like that, because you'd have to tear up the whole floor in order to do the work. So poly can be used to basically lock the, you know, create columns and displace soils. It's just basically compaction grouting to try and keep it from falling apart during an earthquake. But anyway, which is what causes liquefaction. But there's a great, if anybody's interested in reading it, Eagle Lift did a study with, I think it's San Diego State.
University of California, San Diego.
Okay, UCal, so San Diego. So I know Robert knows a little bit more about that, but there's definitely some studies out there. And it's been used in practice. So
Yeah, I refer to their study. It's excellent. The Society of the ASCE, presented in their journal as a peer-reviewed journal. I know that folks in Keller, I think, had some review on that. I could be wrong. Tom, please correct that. I don't want to be wrong on that answer. But the main point is that, they're really working on mitigating vibration with those soils and, locking them up so that their behavior doesn't change in those, high vibration type of environments. And Eagle Lift has spent this substantial amount of, treasure training and also, engineering in order to, really present that case, and I think they've done so. So they've got a site called liquidlock.com that's gets a little bit more into that. Okay. Reviewing any more that we should cover before we call it? Such great questions. I think we should take the rest offline and make sure that we follow up with them. I just want to thank everybody for really presenting, excellent questions that have brought on excellent discussion. Really thankful for the presentation given here. Kevin, thank you very much. I think it was excellent and well done. So I appreciate it. And
Thank you.
if you'd like to say anything or.
thanks for attending, everybody. Keep an eye out for our next webinar. Don't have a set date for it yet, but we'll be making announcements. Our next one will likely be the topic of single component polyurethanes, and so curtain grouting, leak seal, that type of stuff. So keep an eye out for that webinar announcement. We look forward to seeing you there.
Yep, and we will be at the School of Mining grout improvement, chemical grout improvement over in Golden, Colorado. So if you're going to be there,
first week
please,
of August, yeah,
if you're going to be there, please come seek us out. So, and again, there'll be a post survey after the close of this webinar. Please fill that out. Really helps us improve our webinar quality. And also, if you're seeking a PDH, please make sure that you definitely fill that out and let us know if you're going to get a PDH certificate. All right. Thank you all and have an excellent weekend.
thank you.